Okay, I'll start with you this video regarding the triangular factorization. Okay, we'll start with triangular factorization. Okay, triangular factorization, usually we have an equation, a linear equation of a matrix A times X equal B, and we want to determine or to find X. Okay, we know that X will be equal A inverse times B. Okay, but we want to simplify the solution according to the matrix factorization. Okay, we assume that A can be decomposed in L times U, where L equal lower triangular matrix, and U is equal upper triangular matrix. When we do that, then we can use backward and forward substitution to solve the equation. Okay, basically L is equal to 1 1 1 1, and then here you have L2 1, L2 3 1, and so on, and here 0 0 0 0 0 0, and here you have L, okay, 3 2, and so on. Okay, so the upper part, the upper triangle has a 0, while the lower triangle has a diagonal of 1s, and the other elements are full of elements. While U is equal to, we have, let's say, U11, U12, 22, U33, and so on, and you have a matrix here, while zeros in the lower part. Okay, so when you use this one, we can utilize the lower triangle matrix to determine forward substitution, and the upper triangular matrix, we utilize this for backward substitution. I have made actually a program using MATLAB to demonstrate this to you. Okay, let's see how we transform the matrix A to L times U. So basically what we say, L times U is equal A. Okay, so first we will start. We define a matrix, a unity matrix. Okay, matrix full of 1. Okay, and here 0, and here 0, and the matrix, the other matrix is A. Okay, so if we multiply this times this, this will give you A. Okay, now we perform our process by modifying this supposed to be L, and this supposed to be U. So we want to modify the identity matrix L, okay, and modify A, so we end up with the process. When we do the process, we end up with L and U is equal A. So times. So how we do that? It's very simple. First, we take A. Let's assume that this is A, matrix A. Well, here we have A11, A12, A13. Let's say 4 by 4 matrix. Then we have A14, then you have A21, A22, A23, and A24. Okay? In MATLAB, I defined actually matrix A. Let's see what is A. A is this matrix, okay? So we want to factorize this matrix to L times U, where L is the lower triangle and U is the upper triangle. And again here we have A31, A32, A33, and A34. And A41, A42, A43, and A44. Here, if you look at the first elements, this is A11, this is A12, this is A13, this is A14, and so on. This 9 is A22, this is 3 is A33, this 5 is A44, and so on. Okay. I'm actually using the tablet to demonstrate for you the things, and meanwhile I use also MATLAB and video it on a camera, so you can you'll be having two videos, one for the MATLAB and one for the tablet, but utilize both of them to understand the topic. Okay. Now what we want to do is to first eliminate all the elements in this column. We want to make these zeros, okay, and we keep the first row. So how to do that? Simply, we can what we do, we keep the first elements, the first row as it is, A12, A13, and A14. So that belongs, we keep this row 4, 5, 3, 2 as it is, okay? And then we multiply this times, let's look at the first elements. What we have, A21 here. We want to have A21 also here. So when we subtract them, we get 0. So what we come here, we multiply this by A21 and divide by A11, okay? So if we divide by A1, multiply it, we got. So when we subtract that, we get a 0 here. And elements, okay? Again, we do the same for the second, this is for the second row. When we come to the third row, we want to get another 0 here, and X, and X, and X here, okay? Third row, X, X, X. So eliminate the first columns. So for the second row, for this row, we multiply this by A21. For this row here, we multiply that. I will just erase this one. For this row, for the second row, we multiply this by A31 divided by A11, okay, to obtain this one. To obtain this one here, okay, we multiply, I'll erase this, we multiply this by A41, okay, A41 divided by A11, okay? Now, meanwhile, if we do this, that's the first step, we come to the lower part. This is the upper, this is the lower. What we do, originally this lower has 1, 1, 1, 1 here, and 0 here, and 0 here, and 0 here, 0 here, 0 here, okay, 0 here, Okay, let's assume that's a 4 by 4 matrix. And we have also zeros here. 0 here, 0 here, 0 here. These three parts here, okay? In here, we put the same one here, okay? Now this one comes to here, okay? We put here A41 divided by A11. And we, okay, this matrix comes here. And this one here, A31 divided by A11. And, okay, this is scan. And for this part here, we have A21 divided by A11, okay? So, any operation we do here, okay, we just bring it at this location here. So when we do the first elements here, we zero these ones here and here. We insert the elements here. We insert them in the first column here. Okay. So it's so simple. That will be the first step. We eliminated the first column, zeros in the upper, and we inserted the elements in the lower. We are trying to fill up the lower triangle matrix and also get rid of the lower part of the upper triangle matrix by modifying these things. That's the first step. When we come to the second step, now, second step, what we have A11, A12, A13, and A14, and we have a 0, 0, 0 here, and X, 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 X. The second step, we want to eliminate these ones, make them zeros. We repeat the same procedure. So this is U, and this is L. We repeat the same procedure. Here we have 1, 1, 1, 1, and here all zeros. And we filled already this one, we filled already this one, we filled all this. Now, these two elements, we do the same, but we do the operation for this matrix. Let's assume that here we have what? A22 bar. Okay, after the modification bar. So, and here we have A32 bar. So what we do, we multiply this elements times A32 bar and we divide by A22 bar. Okay, this one here, to do the operations, that if we multiply it and subtract this from this, we obtain the modification of the second row. Same when we come to this one, we will substitute instead of A bar 32, it will be A bar 42. And this one we insert it here. Okay? And when we do the second part, okay, for this one, we just replace that. We replace this by A42 bar, okay? And when we do this one, we bring that in this one here, okay? So when we modify these two elements, make them zeros, we bring these two elements to this place here. So you get X and X here, okay? And then we continue the same procedure than what we have here now. L, U, and L. So what we'll be lifting? A11, okay, A12, A13, A14, okay? Then here you have zeros, and here you have A22, let's say bar, X, X, and here you have zeros. What is left is this matrix. Two elements, 2 by 2. Here you have X, 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 x. Now we repeat this, we repeat the same procedure. We take this one here and multiply this by xx over xx, okay, over x whatsoever. What you get in here, you multiply this by this one and divide by this one, okay? In here, we get the same. It was 1, 1, 1, 1. Zeros here, we get an x. That's the first step. And this is from the second step. Now this is the last step here, x. So we bring this, what we multiply to this one here. And that would be the final step. So finally, we'll be having u and we having low. Where low here is 1, 1, 1, 1, and here we have x, and here we have 0, while here we have, let's say u1, 1, u2, 2, and so on, and here x, and here 0, okay? So that we finalize the first step. If I use in the example, let's just demonstrate by an example here. In this example, we have an A. We go to MATLAB. We'll see this A is 4, okay, and 5, and 3, and 2, and 1, 9, 3, 2, and -1, and -2, and 3, and 1, then 1, 3, 2, and 5. This is the matrix A, as you see it in MATLAB. This is A. Now what I would do, I will modify that. I'll construct this first step. What I would do, I will assume that I have L equal 1, 1, 1, 1, 0, 0, and U equal A. Okay, that's the first step. Let's look at the program in MATLAB. You will see it in the other video. Okay, let me just bring it open. Okay. Let's go to the editor. I want to open. Let's see, find where it is. Find files, maybe here. Open. Let's get open. Yes, it should be in the desktop here. Let's go to your folder here, EENG2005. That's the triangular. Okay, let's open it. Okay. Now we have it. This is a triangular factorized. This is A, this is B, U equal A, L equal I4, that is L here. I, it means identity matrix, and it's 4 elements. Okay, so the first step, we want to print these things. First step, okay, 2, 4, let's see. Let's run it and demonstrate it for you, okay? Triangular, okay, this is a triangular, okay, very good. You see it there. The first step, here we have A, this is A, matrix A, and we have L, which is an identity matrix, and U is the same as A, okay? The first step, what we are modifying, in upper, we eliminating these 4 zeros, okay? These 3 elements, and we transfer them to in here. So let's look at the first one, okay? The first one, what we have here is 1. We want to eliminate these 3 columns. The first one we have 1, and here is 4. So we multiply this 4, 5, 3, 2. This is A1 all. What we want to do, we multiply this, okay, this elements times A21 and divide by A11. Now this is 4 and this is 1. So it means what? This element is 1 over 4, which is 0.25. That's why you see it here. This element, we insert it here, 0.25. Okay? You get there? This one here is 0.25. Okay? Because of this one. Okay? Now, when we come to the second part here, here we have -1 here. Okay? Here we have -1. So we multiply A1 all, we multiply it, which is equal again 4, 5, 3, 2, we multiply it by A times A31 divided by A1. And this one is equal, A31 is -1. So -1 divided by 4, it will be -0.25. Okay? And if we look at this -0.25, it's in here. Okay? So what we are doing, and we come to the other, the last one, okay? A1 all 4, 5, 3, 2, we multiply it by A41 divided by A11. And this one here, if we look at it, we go back, A41 is 1, so it will be 1 divided by 4, it will be 0.25, okay? So that's why you see in MATLAB video, we have 0.25 here, okay? Now, to do the first step, we want to modify lu, okay? Now, originally what we have, we go back to it, 4, 5, 3, 2. Now we come to the second element. What we have here, okay, 1932. Now we multiply the first element, okay. How to get to this element here? We take this, the first element, okay, 4, 5, 3, 2. If we multiply this times 1 over 4, we get what? 1, 5 over 4, 3 over 4, 2 over 4. Okay? We get to that. So this, we get to that. Then what we come to the second element here, A2 all is equal what? The second row, which is go back to the second row from A matrix. Let me just do it in MATLAB there. Let's see. This 1932. 1932. Okay, that. Now, let's say this one is H equal. Okay, and you have H. Let's say minus H is equal 1, 5 over 4, okay, 3 over 4, and 2 over 4. Now, if we subtract this minus this, A2 all minus H, 1, 1 minus 1 is 0 here. We put 0 here. Then 9 minus 5 over 4. 5 over 4 is 1.25. 1.25, right? Then 9 minus 1.25 is equal to, let's do the upper, okay, is 7.25, right? This minus this will get 7.25, okay? Now 3 minus 3/4 should be 1.25, okay? It should be 1.25. 3 minus 3/4, that's 0.75. So 3 minus this minus this, 3 minus, it should get 2.75, okay? And 2 minus 2 over 4 half, 2 minus half, you get 1.5, okay? So that's the first step, okay? The same we do it for the other row. We get a 0 here, we get an x and x and x here, we get 0, x, 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 okay? Now this, you can see it in MATLAB, the first step here. The upper is 4, this row is the same, so we eliminated these elements and we modified all these elements here, okay, all these elements, okay, these elements, we modify them, these elements we modify them, and what we have here is, look, this is 0, this becomes 0, this becomes 0. Now, in multiplications, if we look at them, and here, these are 3 elements. The first is 0.25, and the second is minus 0.25, and the third is 0.25. Now we insert them in here. Okay, we come to L. We have 1, 0, 0, 0, then we have 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0. That was the original identity matrix over. Now, these are 3 elements here, which is 0.25, this one 0.25, and this one is minus 0.25, and this one is 0.25. We insert these 3 figures in here, okay? We insert them into this group. So here 1 over 4 minus 1 over 4 and 1 over 4, okay? So that's first step. Then we go to step 2, or second step. We do the same, but now we are interested to fill in these 2 zeros here, okay, these 2 zeros, and modify the upper also. We want to make these 2 zeros, okay? So if we do that, we reach the second step. I go to MATLAB program there here, okay? Now that's the first step. This is the original ALU. A is the matrix, L is the lower, but it is the identity matrix, and the upper is A. We didn't do anything yet. So the first step, okay, we get the lower, these 3 elements, 0.25, minus 0.25, 0.25, inserted here in the first 3 elements, in the first column, while the rest of the elements are kept the same. In the upper, we managed to modify, to eliminate the first 3 elements in column 1 to 0, this one, this one, this one, this one, make them zeros, and we modify these rows here, okay? All done in the program. It's easy, you can program. Thus, we finished the first step. In the second step, we do the same. This, in the lower, skipped there. Now we modified these 2 here, using the 3 by 3 matrix here, okay? And in the upper, we eliminated these 3 zeros, and we eliminated also now this 0, okay? In the third step, we do the same. Third step, okay? Now, that's from the first step, these 3 from the first step, these 2 from the second step, and this element from the last step, okay? And now you see that L is a full lower triangular matrix with diagonal elements equal 1, and off diagonal elements are there. All the upper elements are 0 because we did not interfere with them. And the upper triangle now, you have this 0, this is 0, that's from the first step, and this from the second step, and this from the last step or third step, okay? So finally we have, if we follow this, okay, we'll be having L times U equal 8. Okay? Now this is lower 1, 1, 1, 1, and this is 4, and this is 0, times upper u11, u22, and so on, x and 0. This is equal to, okay? Now what we want to do, we say that ax equal b, find x equal how much, okay? So what we do is say L times u times x equal b, okay? Now let's assume this is equal to y. So L times y equal b. Now what we have is L times y equal b. Now L, it means this 1, 1, 1, 1 x, 0 times y1, y2, y3, y4 equal b, which is b1, b2, b3, and b4. Now to solve this one, we can use forward substitution, using forward substitution. Then y1 equal b1, y2 equal b2 minus y1 times L21. Well, this is L21 here, L21, okay. So L21 times y1 plus 1 times y2 is equal b2, okay. So b2 minus y1, and we continue that. y3, so b3 minus y1 L31 minus y2 L32, and so on, okay. We do it that way. We find y, vector y. Now Ly is equal, now ux is equal y. So ux is equal y. Now we know y, but we don't know x. We want to find or determine x, okay? So in x here, to determine x, I'll show you also in here. To determine x, we use what? Backward substitution. We have used forward substitution first to determine y, and this is y transform. Because y is a vector, a column vector, while y transpose is a row. So I want to just write it as a row vector, so that's why we calculated from that. Now for this one here, what we have, this is u11, u22, u33, and u44, okay? Let me just erase this one. u4, okay? And here you have u12, u13, u14, and so on. u23, u24, and u3, 2, 3, 3, okay? This is 3, 3, sorry, 3, 3, you see, and this is 3, 4, and 4, 4. And all here you have 0. Now this times x1, x2, x3, and x4 is equal to y1, y2, y3, and y4. Now we know y1, y2, y4. This we calculated from the forward substitution. Now we can utilize backward or back substitution, backward substitution. Okay, how to do that is very easy. Since in the forward substitution the diagonal elements are I1, so we do not need to divide by anything, because we are dividing by 1. In here, x4 is equal 1 over u 4, 4, that's the one here, okay, times, okay, y4. Then x3 is equal to 1 over u3, 3 times. Now it's y3 minus y3, 4 times a or u3, 4. u3, 4. Then we come to calculate x2, 1 over u, 2, y2 minus y, because this is x2, means we calculated x2, so 2, 3, y3, we want to calculate x, so it's y3, we want to calculate this one, so we don't know x2, we have to calculate it, x2, okay? So it should be y2 minus, then we multiply this times x3 and this times x4. So we'll be, let's go back again, let's take this one here, okay. So what we need is y2 minus u upper, okay, 2, 3, x3 we know it, minus u2 for x4 now we know it, okay? And finally x1 equal 1 over u1, 1. Now here we have y1 minus, start, u, okay, 1, 2 times x2, we know it now, x2, minus u1, 3, x3, minus u1 for x4. So this is the back substitution. In here, let's correct that. There's a mistake here. Okay, let's correct this here. There's a mistake here. Okay, this y3 minus here, u should be 3, 4 times x4. Okay, x4 we know. So first we calculate, we determine x4, then we come to x3, we need x4 here. When we come to calculate x2, okay, we need x3 and x4. And we want to calculate finally x1, we need all of them, x2, x3, and x1, okay? So that's the last step for substitution. Let me demonstrate that program for you, what we have. I will upload that program for you. Here is triangular factorization, okay? We defined A. B is 1, 3, 2, 5. U is, that's the first, the initial, okay? We assume the upper is A and the lower is 4, but this is not actually a lower, this is not actually upper, okay? Because we need to modify this U until it comes a full upper matrix. And again, this L, we want to modify it to become a full lower triangular matrix. So we print first initial, then we print what is A, what is L, what is U. L here we made it as I, which is identity matrix, and U is A. Now we start a modification. First step, we go from 2 to 4 because we want to eliminate from the first column. We want to eliminate the first elements in the column matrix. If we go back to here, okay, what we want is to eliminate this element and this element and this element. We want to make them 0, okay? So we go in this loop from 2 to 4, okay? We calculate we divide K1, which is, for example, we start Q here, then it's 2, 1 divided by 1, 1. That will give me the element of the lower matrix 2, 1. So it started from 2. And we repeat 3, 4, we do the same here. So we modify L here, and we modify, how we modify U, upper triangular matrix, we subtract The same row, that's the row matrix. So 2 to 4, when you start at 2, it means what is 2? All the elements is equal to the elements of the upper 2, the row 2, minus row 1 times this factor, which is U21 divided by O, which is the first element in here. And we repeat it. So if, according to this, we finalize the first step and we print it. What is L? What is U? Okay, generated from the first step. Okay, so if we go back to the editor here, that's the initial, this is the first step. Okay, we filled up the first 3 elements from L, and we eliminated the first 3 elements of the first column from U, and we modified accordingly all of this. We repeat for the second step the same way. Okay, now I'm demonstrating this on MATLAB. Okay, if we go back to the program here, the second step, then in the first step we started at 2. Now we'll start at 3. Start at 3 because we have 2 elements, 3 2 and 3 4, and we modify this. Instead of 2, this becomes instead of 1, this becomes 2. So we want to eliminate 3 2 and 4 2. Okay, from U, and insert these modified, which is U first 3 2 divided by U 2 2, and then U 4 2 divided by, we modify the lower by filling that those elements with these values, and then modify the upper by subtracting from the same row, third row, okay, and fourth row by this multiplied by second row, okay, and then we obtain, if we go back, we obtain the second step. So second step, you see, now we are filling this matrix. It was 0, these both elements were 0, okay, now we fill them, and we modify this, they become zeros, okay, eliminating. And then the final step is we go from 4 to 4. That's third step, 4 to 4, because we left with only one element, which is U4 3 divided by U3. That will fill up the lower triangular matrix, which is, if we go to the third step, so we want to fill this one. This one was 0, now we are filling it, and we are eliminating this, making it 0. That's all done in the last step, okay? Then we print the last step. Then when we come to forward substitution, we first assume that Y is a column vector, 4 elements, okay, of 0 values, and we will find for substitution first obtain element 1, Y1, then Y2, then Y3, then Y4. And once we know these Y's, we go to the upper triangular matrix and do the process again to determine the X value. First, it's backward substitution. First, we determine X4, and then from X4, then we determine X3, and then X2, and this X1. Okay, you see here we divide one UKK. So U33, U22, U11, and the first one U44. In the forward substitution, these were ones, okay, and here they have a value. Then we print Y and X as seen here, okay? Very good. So to make sure that what we did is right, okay, from MATLAB, when A is equal, let me go to MATLAB again. When A is equal 4, 1 minus 1, 1 minus 1. No, here, sorry. Okay, let me correct that. This is not, okay. So we have 1 here and minus 1 here, and let me correct this. Okay, and we have 1 here. Okay, that's A, and then 5, 9, 5, 9, minus 2 under 3, minus 2 under 3, and 3, 3, 3, 3, 3 under 3, and 2, okay, and then 2, 2, 1, 5, 2, 2, 1, and 5. This is basically A. And we have B is equal, let me see what is B here, okay, B, what is B, okay, what is B? B is, where's letter B? B is, okay, so B is 1, 3, 2, and 5, okay, and we have AX equal B. So what we want is to determine what is X. First step, we make L times U equal A, so we obtain what is L, okay. L turns out to be the final L. Let me just put it to L. We get L is 1 here, and 0.25, 0.25, and minus 0.25, okay. I want you to go through the program, understand it step by step, okay, and calculate these things. Understand how the program calculates these elements. Then here is 0 and here is 1. Diagonal always 1. Then minus 0.968, and then here you get 0.2258, 0.2258, okay, and again you get 0 here, okay, and 0 here and 0 here. The third one is 0.187, then 0, 0, 0, and 1. So to demonstrate this, just separate them, you'll get that, okay. So this makes basically L, the L matrix, and you obtain U, upper triangular matrix, as, let me find U from MATLAB. This is U, okay. So you get 4. That's the first row. It doesn't change, okay. 4. You get 0, 0, and 0, and then you 5, but you get 7.5, 0.75, okay, and 0 and 0 here, and you get a 3. The first row is the same, it doesn't change. 2.25 and 3.9677, and here is 0, and then 2, 1.5, and 1.6, 452, 6452, and then 3.8, 537, 537. Okay, you obtain that. Then the second step, you say that y equal b, and determine using forward substitution. Find y will equal to, let's see what is y. Y is equal small y, yes, y tends to be 1, 2.75, 2.5161, and 3.6585. And finally, use L times X equal Y. and you do lower. This is a lower triangular matrix. Okay. Sorry, let's see, L times U equal I, so we use U. No, this is not, let me correct that, okay. Here is not U, here is L times, okay, here what we have, L times Y, okay. And then we use forward substitution, that's correct, L with, okay. Then, let me correct this one. Then we use U times X, and then we use for this backward substitution, okay, to determine X. X will be, in this case, let me find out from MATLAB, X is equal minus 0.5316, and then 0.1013, and then 0.2405, and finally 0.949. Okay? Now, to make sure that we have the correct answer, this is X here. This also should equal to X should equal A inverse times B, which is written in MATLAB, inverse of A times B. Okay? If we do that in MATLAB, okay, so we know now X. Let's see, this is X, okay. X is equal to that. Let's invert. Since we know B still we have it, A we have it, let's invert it. Okay? Okay, invert A. If we invert that, this is the inverse matrix. Okay? If we multiply it by times B, it should give us the same X. Okay? So that's the same X. If we say minus X, for example, minus X, it should give us something like 0, 10 to the minus 15. So we are right, we are correct in determining, to determine X, okay? So, actually what we were doing is we are calculating this one, but we doing first triangular, we factorize this, doing triangular factor, and then we use forward and backward substitution instead of doing this operation. It's simpler than inverting this, okay? And so on. It's the same way if you look at it, okay? A inverse, it means LU, okay? Inverse of A, okay? Of A, this one, it should be the same as the inverse of L times U, okay? It should give you the same values, because L times U, L times U should equal to A, and this is A. We say, okay, minus A, it should give you something like 0, okay? Oops. So that's almost 0, it's 0, only that element here. This element here is what is here. It's actually minus 0.111 times 10 to the minus 15. So that's okay, we are there. This just to make sure that we are doing the right thing, okay? I will upload this program here for you, Okay, this is the program. Its name is Triangular. Okay, I'll upload it to you through the Blackboard and through the WhatsApp group also. I want you to type it. You type it, understand how it works. Okay, and run it. Change the matrix A. Okay, change the matrix B. Do it the same. Do the things the same way. Okay, and if you like, what you can do, this is a 4 by 4 matrix. You can make it 5 by 5 matrix. Then in this element here, B will be 5. You add something there, another element. But modify the program then in this way. That's the initial step is the same. Instead L equal I4, you make it L equal I5 here, okay? And when you come to do this, the first step is the same. Here you say from 2 to 5 instead of 4, 2 to 5, okay? And here is the same. And then you go to the first step, okay? You print it out. But to print out these things, you see that the print here command, I have 11F, 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 you have 4 values, okay? Because I have a 4 by 4 matrix element. If you modify to 5 by 5 matrix, then you need to insert another. Just delete this one, insert it again. So you must have 5 elements, okay? That you learn that how to do it. Since we have only this one, okay, only 4 elements, then we have percentage 11F, percentage 11F, because 1, 2, 3, 4. We need to modify that also, okay, to get the printout the same. And here then 2 to 5, okay. Then if you go to second step, 3 to 5, 3 to 5, okay. And then you modify also these ones. Then third step, 4 to 5, here 5, and the last step 5 to 5. Okay, you can practice that, and when you come to forward substitution, say I will create one 5 1 instead 4. You change it 5 1, y1 y2 y3. It's the same way, okay, but you add y5 and modify this equation. Say for backward substitution, you don't start with you say x is 5, okay, 0 is 5 1, but you start with x5 instead of 4 and modify it the same way. I'm sure they'll be able to do that, okay? Go through it, practice how you understand, you should, okay, master this triangular factorization, understand the program, how it works, okay? Modify it for a larger matrix, say 5 by 5 instead of 4 by 4 matrix, okay? And I'm sure you will digest everything there. So for the next video, I will I will do a video for you for the curve fitting. Let me okay, demonstrate how we find the parameters of a linear equation to best fit an experimental points such as Ohm's law or whatsoever, okay? So I will talk to you later when that video is ready. I will upload these 2 videos actually, what I have made. One video through the tablet and one video through this MATLAB here. Once you practice, you should watch both videos, okay? And I will upload also this program for you through WhatsApp group and the Blackboard, okay? So once I finish that, it should be by Friday or before Saturday even, I should manage or make that video for the curve fitting and send it to you, okay? So see you later, okay.